So let's start. So good afternoon, everyone. Dear authors and all the invited guests. A very warm welcome to technical session 12C, the last session for today. Myself Yashita, and I'll be moderator for this session. I'll be making sure that everything runs smoothly. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communication Technology for Intelligent Systems, which is ICTIS 2026. The 11th edition of the conference is being organized in a hybrid mode. So, the physical event was held yesterday in Bangkok, Thailand, while the virtual sessions are being conducted via Zoom from 9th to 11th April, where people from all over the world are present with us. So, I hope that you all will enjoy today's knowledgeable and interactive sessions. So, in this session, we will be having total 10 presentations. Each presenter will be given 8 to 9 minutes for presentation, followed by 2 minutes for question and answers. I will be giving a gentle reminder at the 8th minute just to help everyone stay on track. Also, small request to every participant that please stay connected with us till the closing remarks. We promise that this session will be worth it. If you have any questions or updates, feel free to drop them in the chat box anytime. Me and my co-host will be addressing them. So before we begin, I would like to introduce you all to our esteemed session chair, Dr. Natima Bamanza. Is a senior lecturer in the Department of Information Technology at the Central University of Technology, Free State, South Africa. With approximately 19 years of academic experience, he specializes in human-centric computing and pedagogical technologies. His research interests include HCI and UX, pedagogical interface agents, cybersecurity and blockchain, bibliometric analysis, and emerging technologies. So, welcome to the session, Mamanza sir.
Thank you very much. Thanks also for the opportunity.
You would like to give some welcome remarks to everybody?
Okay, so this is a very nice conference. So in terms of the paper which have been selected here, it was thoroughly reviewed. So if your paper is being accepted for presentation, so it means you really put some effort, you work hard. Congratulations to all of you. So welcome to the session. I'm looking forward to a very interactive session. Thank you.
Thank you so much. So next we have with us Dr. Amol Admuthe, who is a professor and head of Department of Information Technology at Rajaram Bapu Institute of Technology, Maharashtra, India. He has over 18 years of teaching experience at undergraduate and postgraduate levels. His areas of interest include technology forecasting, optimization algorithms, soft computing, and cloud computing. So, welcome to the session, Admuthe sir. You would like to say something for all the participants today?
Yes. Hello, everyone. So, I am working as a professor and head at Department of IT. This is Maharashtra, India. So, once again, I want to congratulate you for contributing to this conference. So, congratulations for solving a problem and writing a research paper. So, what is the purpose of research? The purpose is very simple. We want to solve some complex engineering and real world problems. If your focus is on solving sustainable development problems, then this is quite beneficial for society also. So either you try to solve some problems which are in theoretical aspects or some problems which are directly contributing to the society. So when we are thinking about research, what is the driving force? The driving force is either a technology push or a market pull. And today is the era, so which is focusing on a market pull. So the market and the customers, the end user is asking for some solutions. So this is a time where we can use the existing theories and laws to solve some real world societal problems and contribute to the overall development of the society. So this is the agenda. So which is I'm saying so required in current era. So once again, best of luck for your presentation. So this is a platform for cooperation and collaboration. Learn research done by other researchers and try to collaborate for further research publications. Thank you.
Thank you so much, also for those kind words. So now let's begin with our presentation. So today our first presenter is Viet An Doong. Are you present in the meeting? Let me
Yeah,
check.
yeah.
Okay. So good afternoon. So he is here to present his paper titled as a deep reinforcement learning based adaptive large neighborhood search for commercial territory design problem. So you can share your screen and start with the presentation. So it's
Yes.
a humble request for all the presenters here that you have to finish your presentations between 8 to 9 minutes. So yes, you can start.
Can you see your slide? Can you see my slide?
No, the meeting is visible, not the presentation. Yeah, now it is visible.
Um, Hi everyone. Thank you all for being here today. My name is Dương Việt Ánh. On behalf of our research group, I would like to present our topic on a deep reinforcement learning based adaptive last level search for commercial territory derived problem. The structure of our presentation includes five parts. First, let me introduce the background of our work. The Commercial Territory Design Problem, or CTDP, aims to partition basic units into territories while ensuring balance, compactness, and connectivity. However, it is and be hard, making large-scale problems difficult to solve. Uh, Traditional methods include exact approach, which do not scale well, and ALNS, which depends heavily on manual tuning. To address this limitation, we propose a deep reinforcement learning ALNS framework. By integrating an actor characteristic model, the algorithm can dynamically select operator and harass parameter based on current state. As a result, our methods improve conversion speed, solution quality, and scalability. Next, I briefly review related work. CTDB is an NB-hard problem. Exact methods can achieve an optimal solution but do not scale well to last instance. Heuristic approach, especially ALNS, are more practical and widely used, but their performance depends heavily on manual tuning and heuristic design. Recently, reinforcement learning has been introduced to improve decision making in meta-heuristic, particularly for operator selection and parameter control. Motivated by this, we propose DRALNS, which integrates an actor characteristic model to enable adaptive and data-driven search. Now, I will present the problem setting. We partition n basic units into n territories, each with a center node model as a graph. The objective is to minimize total distance from companies subject to two constraints: workload balance, controller by alpha B, and collectivity. Overall, we aim to create balanced, compact, and collected territories. Next, I will present the ALNS framework used in our approach. ALNS improve a solution through a disjoint repair mechanism where nodes are removed and reinsert to explore new neighborhoods. For the disjoint phase, we use three operators: random removal for boundary nodes, related list by removal for geographically closed loop, and adjacency-based removal for high-impact boundary nodes. For the repair phase, we use first feasible insertion for fast feasible solution and two rigorous insertion for better solution quality. However, operator selection still relies on predefined heuristic, which motivate our learning-based approach. Now, I will present our proposed DRALNS framework. The key idea is to transform the control mechanism of adaptive large neighborhood search into learning-based process using an actor-characteristic architecture. At each iteration, the current solution is encoded into a state capturing solution quality, constraints, compactness, and search progress. The first key contribution is the actor selection step. Um, Instead of predefined heuristic, the actor outputs a probabilistic policy and symbol an action that determines the destroy operator, repair operator, destruction site, and temperature. This allows the algorithm to adapt both the strategy and the search intensity. Next, I in the ALNS execution and acceptance step, the selected action generates a new solution and a simulated annealing criterion decide whether to accept it or balancing exploration and exploitation. The second key contribution is the learning step. We compute a reward based on improvement and the critic estimates the expected value. The advantage indicates whether the action is effective, guiding the actor and critic update. Overall, DRALNF replaced manual turning with a fully adaptive data-driven search strategy. Now, then in our experiment, we use benchmark datasets from Rios Mercado, which are widely adopted and based on realistic industry setting. We evaluated our methods on 40 standard instance and compare it with exact methods, including median-based territory districting problem and quadratic median-based territory districting problem, as well as the baseline ALNS. To further assess scalability, we also test on 15 large-scale instances with up to 1,000 nodes. This allows us to demonstrate both effectiveness and scalability of our approach. In this section, we evaluate the performance of our methods. We compare DR-ALNS with standard ALNS and exact methods on benchmark instance. Overall, DR-ALNS consistently outperform ALNS and achieve optimal or near optimal solution in most cases. For median scale instance, it achieved the best performance in 19 out of 20 cases. Notably, in several time limit scenario, DRALNS even outperform median-based territory districting problem and quadratic median-based territory districting problem, which are designed to produce optimal or near optimal solution. This highlights the effectiveness of our learning-based approach under practical runtime constraints. Overall, the ALNS achieve faster conversion and higher quality solution through better operator selection and adaptive control. In this section, we evaluate our methods on a large-scale instance. We consider companies, constraint violation, and execution time. Overall, DRALNS produce more complex territories and fewer constraints violation, indicating better solution quality and feasibility. A key contribution is computational efficient. While standard ALNS often reach the time limits, the ALNS brings high-quality solutions significantly faster thanks to learning-based operator selection. In terms of conversions, the ALNS improve faster and continues progressing and in later iteration showing a better balance between exploration and exploitation. Overall, the ALNS achieve better quality, faster conversions, and stronger scalability on large-scale problems. In conclusion, we propose the ALNS which integrates an actor critic model into ALNS. The key contribution is a learning-based control mechanism that dynamically selects operator and arrays parameter. This leads to faster conversions, better solution quality, and even competitive performance with exact methods. In addition, DRALNS shows strong scalability, delivering high-quality solutions efficiently on large-scale instances. Overall, our approach provides a more adaptive and robust solution for CTDB. This is the end of our presentation. Thank you for your attention. Do you have any questions?
Yeah, from both the session chairs, any questions for him?
Yes, please. I have a question. Yeah. Thank you very much for the good presentation. It's a very nice work. I just wanted to ask, can you please tell me, clarify for me, what informed you to make a decision to choose ALNS over other framework? Why did you choose that specific one? That's all I wanted to know. Thank you.
Thank you for your question. Um, um, we use actor critic model to evaluate to choose decision destroy operator or repair operator. The first at each iteration, the current solution encode into a state capturing solution quality. We use some neural network, but is lost work the same as actor critic model, and we use actor critic model to select and update learning base. Uh, we compute a reverse by improvement and critic estimate expected value. The advantage indicate where the action is effective.
Okay, thank you very much.
Also, any questions?
Yes, thank you. The research work done is very good. The author have identified a complex problem, and this is belongs to category of NP, and designed a hyperheuristic algorithm. They have compared with exact methods also, but there is a scope to compare performance of hyperheuristic with heuristic algorithms like genetic and particle form optimization, because hyperheuristic will definitely work better than exact. But what about heuristic algorithms like GA, PSO, TLPO? There is scope to compare with these algorithms.
Sorry, can you repeat your question?
So there is scope to compare performance of your proposed hyperheuristic framework with other meta-heuristic algorithms like genetic algorithm, particle swarm optimization. Whether the
Uh,
results are available for genetic algorithm or particle swarm optimization or other meta-heuristic algorithms.
we compare some meta-heuristic is adaptive last label search with exact methods, median-based territory districting problem and quadratic median-based territory districting problem. Then we test on DRALNS compare with ALNS and exact methods.
Yes, sir. This is okay. You have compared with exact methods, but there is scope that you can compare with other meta-heuristic methods which are better than exact methods. And the methods may be genetic algorithm or particle swarm optimization or and colony optimization and other. Thank you. You can consider for future research, sir.
um, um, Compare DRANS with exact methods benchmark. Um, Overall, the ARNS consistently outperform ARNS for median case instance. It achieved the best performance in 19 hour 20 case. With exact methods, which are designed to produce optimal audience, optimal solution. Um, while its consume time limits.
Yes, thank you. Thank you very much.
Okay, so Rupali Vairangde, ma'am.
Yes, sir.
Yes, you can go ahead with the presentation.
Yeah.
Yeah.
It is visible, ma'am.
Yes, it is visible. You have joined from two devices, so you can mute one of the devices, the other one from which you are not speaking.
Now it is audible properly.
Yes, it is echoing. So what you can do is the from which you are not speaking, you can mute that completely so that
I
uh,
have joined from only one device, ma'am.
no, there are two names here, two IDs, Rupali Vairagde. Yeah, now it is one, so you can present it.
Yeah. My slide is visible.
No, no, no. Your slide is not visible. You can reshare it.
Not as visible.
Yes. You have to complete it in 8 to 9 minutes.
Yes, ma'am. Sure. Yeah. Very good afternoon to everyone present here. I'm Dr. Rupali Vairagade, working as Associate Professor in Department of Cybersecurity, Shahan Anchor Kutch Engineering College. Today, I'm going to be present on Lightweight Trust blockchain framework for secure IoT communication under the networks of IoT. Basically, that particular topic it will address the challenges of securing the resource constrained devices using the efficient and the scalable approach. And this work it combine the trust evaluation with the blockchain technology. And the basic aim is to provide the secure communication without the heavy computation, and it is basically focused on the relevant for the modern IoT application. So with this, I will going to be start with my presentation. So basically, we'll have to be discussed about the that is why there it is a necessity of IoT, and how there are the different security challenges are there, and how the security challenges it will going to be resolved with the blockchain technology. So the Internet of Things it will going to be connect with the smart devices, as we know that in day to day life the huge data it has been generated, right? So that all the devices it is used in the area like healthcare, smart cities, and the industry. So these devices are limited in power and memory, and it is making a security difficult. So how to provide the more security to all these particular devices? As we know that because the security problems, it is main concern with the IoT nodes. These are all the resource constraint, as we know that, and the trust issue, it is very confidential whenever we are sharing the data. So the communication between the nodes is critical unsolved problem. So how we are ensuring the secure and the trusted communication, it is a major challenge. That's why the traditional security solutions are not suitable for such environments. So how, and for that we'll have require the new approach, and that new approach, it is how you are integrating the particular blockchain in it. So these are the existing IoT security mechanism, that all the IoT security solutions, it will across the perception networks and the application layers. Within that, the current trust model, it will going to include the reputation based behavior and the hybrid approaches. So that all, it will going to be rely on how will going to be fix the threshold and the lack of adaptability. So this model, it is basically the vulnerable to false data and the attacks like the Sibyl. As we know that if it is a concept of networking, most of the attacks, it will going to be occur. So how that particular attacks, it will handle the dynamic IoT environment effectively. So it is a need of more flexible and the adaptive trust mechanism, ki how the communication it is establishing properly. So these are basically the existing gap, it will be there in the IoT security mechanism. Now, when we are talking about the proposed system architecture, in a proposed system architecture, it will use the three different layers, and that layers, it consists of the IoT node, gateway nodes, and a blockchain layer. So that basic IoT devices, what it does, it will collect the data, but it will not going to be perform the heavy computations. So the gateway nodes, it will handle the processing and the communication task. The blockchain ensures secure, transparent, and the tamper-proof data storage. So this particular structure, it will reduce the burden on IoT devices, and it will also improve the scalability to maintain the decentralization. So how will going to be achieved that, and the solution will be provided with the concept of the blockchain. So this is a basic introduction to the blockchain technology, as we are integrating to provide the security and to reduce the computation overhead of the IoT devices with the concept of a blockchain. So as we know that day to day by the blockchain, it is providing a secure solution to all the problems that it will be there. So the blockchain is designed with the blocks containing index, stamp, transaction data, hash value, and each and every block, it is linked to the previous one to ensure the data immutability. As we know that because the block, it is nothing but the chain of record, and it is a peer to peer network. That's why the transaction flow start from the IoT devices sending a data to the gateway, and it is often verified and the validated using the trust mechanism, because we are integrating the trust over here. So that's why the validation of the blocks are created, and it is going to be added to the chain, and then it is updated with the ledgers, it will across the nodes. So this is a basic structure, the basic blockchain structure, as we have already discussed. So these are the objective that we are basically working on. So how we are integrating the lightweight trust evaluation framework with the blockchain algorithm, and how it will going to be control the overall blockchain structure of a network for the evaluation of your IoT security in the wholes. So this system architecture is basically talking about what exactly the device security model it is there, what kind of that is the derived requirement. So derived requirements are the security analysis, blockchain implementation, trust integration. So most focus which is related to this paper, it is how the trust it has been integrated and how we are implementing that all these services. So the dynamic trust evaluation, when we talked about the dynamic trust evaluation mechanism, so basically it will uses the dynamic trust evaluation, and it will update the trust score over the time. So with the help of mathematical computation and the implementation, we're going to be show that how the trust has been calculated. It is based on the communication behavior and the interaction history. The metric likes we have considered over here is the packet delivery rate, latency, and the consistency consider. And in that we have used a TOPSIS model, which is for the trust node selection. So the high trust nodes are allowed to be participate in the validation, and it will reduce the impact of your malicious node in the network. So this will be overcome with the help of that is with the help of the diagram, how the trust evaluation and the trust node selection set will be there over the network, how the blockchain it will be integrated in it, then we are applying the consensus mechanism, then block it will be verified, and then that verified block it will be added to the blockchain, and these are the parameters which will be going to be considered, or the structure of a block, then transmit the data through the packet through the trust node, then the destination and the receiver. Now, the proposed framework, it will integrate the blockchain, as I have already told you, the trust-based mechanism for the secure IoT communication, and it is mostly focused on the lightweight computation, which is suitable for the resources and the limited devices. This system, it basically allow the trusted node participating in the decision making, and it will improve the reliability and the fault tolerance. Overall, it will ensure the secure and the efficient communication in the IoT environment. So how the trust-based routing it will be achieved, that it is shown in over here. It will improve the routing performance by selecting the node that is having the high trust level, and number of nodes it will be there. From that, we're going to be select a node which is having the higher trust level. How it will going to be compute with the help of this formula, the source and the destination. So this mathematics it will be used to compute the highest trust level. Then if it is any error it will be there, it will going to be compute with the parameter that is star. While transmitting the data, if any error it will be there, it will be calculated with the error formula. Then we are calculating that is the trust it has been evaluated with the help of this. In that EI and the E source, the energy of the ith and the source node respectively. So likewise we are introducing the forwarding ratio and this. So for the result evaluation we have used, for the performance evaluation we have used, it will be evaluated using the simulation and the realistic IoT environment, and it consider the different factors as I have told you. So based on that, these all the parameters it will be considered. Now when we have compute the performance evaluation of the same, the system it is evaluated using the simulation, and it is going to be focused on the energy consumption and the network delay and the throughput. That all the result it will show the reduced energy usage due to the limited participation in a validation, and it will going to be calculated if you are not using that is delayed in the non-trust, you are not using the blockchain, and the delayed in the trust mechanism, that is a lightweight framework. And we have tried with the different number of node. For example, it is given the number of nodes it will be a 30, and here in this the number of nodes it will be the 100. So you can see the comparison if you are not using the trust mechanism and if you are using the trust mechanism. The difference it has been shown in here. Next parameter that we have considered the energy. Again, the energy consumptions in between the trust and the non-trust, so that all the evaluations result it is showing. Now we have integrated the blockchain into the trust-based routing. So when we use a blockchain, it will perform the consensus protocol for our proposed work. And within that, we have considered the two main component. The first one it is a lightweight trust evaluation framework, where we are considering the this trust evaluation, and the proof
Sorry
of,
to interrupt, ma'am. You have 2 minutes remaining. You'll have to wrap up in it.
yeah, the powered blockchain framework for the integration with the network. So we have considered the structure of block, and a base of this, the proposed lightweight proof of work mechanism. It is designed for the IoT system, and it will going to be reduce the computational overhead and the energy consumption. The fewer nodes computing the leads to the faster block creation, and it will going to be improve the efficiency and the credibility. So this is the block verification process, ki how we are identifying the block and how that particular block it is being added to the blockchain. So for that we have tried it with a different attack, with blockchain and the without blockchain. So the few basic attacks we have considered: Sybil, masquerade, flooding attack, and based on that we have evaluated again the network performance, ki while using the blockchain and without using the blockchain, what kind of parameters it will going to be performed, and how it is going to be generate these things in it. So the proposed proof of work it will design for the IoT environment. Based on that, we have generated the result, and with the each parameter we have evaluated energy consumptions, delay, and the energy. So this is the lightweight trust-based blockchain framework. That framework it will propose the proof of work. It is designed for the IoT environment, and only the trusted node participated in the validation. As we have discussed the lightweight trust framework, it will reduce the energy consumption and the computation, and this approach it will make the blockchain feasible for the IoT, and it is giving a better secure solution for the IoT devices. So the simulation and the result discussion, we have considered this parameter: energy consumption, network delay, and the throughput, that I have already discussed. So it is providing the trust aware lightweight proof of work concept mechanism that we have used from the blockchain for the secure devices. So it is providing the faster computations to it. So the conclusion and the future work it is the proposed system, it will improve the IoT security using the trust-based blockchain, and it will going to be achieve the better performance and the efficiency. And basically, it is suitable for the real world application, and it include we can integrate again the machine learning we have tried. So if we're going to be, we'll try to incorporate the explainable AI in it. So the large scale testing and the advanced attack detection, it is also planned in the future work for the real world testing. Thank you so much.
Yes, thank you, madam, for the presentation. Whether I'm audible?
Yes, sir, you're audible.
Yes, so there are three questions from my side. First, how trust is calculated? Second,
Okay.
why you are saying this is a lightweight protocol? And third, you are saying this is applicable to real world scenario. So whether you are tested on different scales, what about the
Yeah.
scalability issues?
In that, the first question answer it is we are using a TOPSIS model for this. So with the help of the TOPSIS model in it, we are calculating because it is used to select the base node based on the trust score. So that TOPSIS model it is used for the evaluation of this. Based on that, we are.
But you are not explained how model Topsis model here in this presentation.
It is there in the presentation, sir. I think
You have mentioned Topsis only, but how it is implemented? What are the parameters for implementation of Topsis is not explained. Okay, please go ahead.
these are the parameters that we have used different mathematically we have computed, sir, and it will going to close the ideal solution with the higher
Ma'am, your screen is not shared actually.
yes ma'am. Now it is
Yeah,
visible.
yes.
So within that we have calculated with the help of the TOPSIS model, sir, and this is a TOPSIS model where the mathematical computation it has been done, and with the help of the TOPSIS model we have selected the based that is node to evaluate the trust score. We have integrated the blockchain at it, but we are training with the different samples. So we'll try to integrate the machine learning concepts in it so that it will going to give you the proper scalability to our model.
Okay, whether you have tried with simple methods like AHP before implementing Topsis, whether you have think about AHP method.
No, sir, we have not tried, but we'll try to incorporate in our research.
Okay, so when before going for AI methods, you can think for simple statistical methods.
Okay,
And
sir.
when you are saying this is lightweight, why you are saying this is lightweight?
Uh, Based on the we are saying the lightweight trust base it is because whatever may be the models that we have tried on a data set, sir, within that we are not getting the proper accuracy with the which particular node will be selected. So we have done the analysis based on that. So we
But
have
the lightweight is concept is something different. Okay, no head. But when you are going for real-time applications, you
okay.
need to check whether it is applicable for large-scale data sets also.
Yeah,
Thank you.
we are trying to inculcate on the healthcare application, sir. We are doing research on the healthcare application. So basically, we are trying on the healthcare devices, ki how we can provide the lightweight approach in terms of energy consumption.
Thank you, madam.
Okay, thank you, sir.
Okay, Mabanza sir, any questions from your side?
Yeah, there's just probably a comment, a question. So I just wanted to know, in terms of your proposed solutions, so what are what are the limitations of your solution? Because you are talking about the real world. I'm not sure if you have already tested it or you're planning to test it. So in terms of limitation for your proposed protocol, what was the limitation? Did you overcome that? How did you do that? Thank you.
Basically, we have tried only on the few attacks, so we have not tried because only on the Sibyl attack and the flooding attack we have tried. In the future, we are trying to be worked on the more advanced attack detection so that we can going to be plan on the future. So we want to include the machine learning integration too, and we want to scale our system on the large scale testing so that it will be providing us a better solution with the help of blockchain technology in a healthcare domain.
No, thank you very much.
Thank you, sir.
Okay, thank you, Rupali ma'am, for your presentation.
Thank you, ma'am.
So next we have Samantha Angelique Ruiz. Are you present in the meeting, Samantha?
Yes, am I audible?
Yes, you're audible.
Yes.
So she's here to present her work titled as Agroclimate Machine Learning Model for Rice Yield Prediction in the Leucos region. So you can start your presentation, Samantha.
I can't share my screen, so I
Yes,
requested.
you can. I've stopped sharing my screen.
Okay. Is my present? Can you see my presentation?
No, it's still a black screen. Right. Yes, it is now visible. You can start.
Okay.
Yeah.
Thank you. So, good day, everyone. So, it is a pleasure to present our study titled Agroclimate Machine Learning Model for Rice Yield Prediction in the Ilocos region, Philippines. So, this research investigates how machine learning and historical agroclimatic data can be used to predict rice yield and support more informed agricultural decision making in the region. So the Ilocos region is one of the key agricultural areas in the Philippines and is among the top 10 rice producing regions. However, rice production is increasingly affected by climate variability and unpredictable weather patterns. And traditional yield prediction methods often rely on historical averages and expert judgment, which may not fully capture these uncertainties. And with the availability of agroclimate data such as temperature, rainfall, and humidity, there is an opportunity to apply machine learning to better understand patterns and improve prediction accuracy. So this research has four main objectives. First is to identify and pre-process agroclimate data features. Second is to determine suitable machine learning models. Third, to evaluate model performance. And fourth, to integrate the best model into a web application for prediction. So here's the conceptual framework. So it illustrates the entire process of the study. So it starts with data gathering, followed by pre-processing, data splitting, model training, evaluation, and finally prediction. And each stage plays a critical role in ensuring that the final model is accurate and reliable. So here, you can see the data gathering procedure. So we collected historical agroclimate data from visual crossing and rice yield data from field rice. And these data sets were combined to create a comprehensive data set for analysis. Then next, during the data pre-processing procedure, we perform several important steps. First is the data cleaning, where we handled missing values, we removed duplicates, and corrected inconsistencies. Second, the feature selection, where we identified the most relevant variables for prediction. And third, the data transformation, where we prepare the data into a suitable format for machine learning. So these steps ensure that the data set was accurate, consistent, and ready for modeling. So our data set was divided using an 80-20 split, where 80% was used for training and 20% for testing. So this allows the model to learn patterns from the data while still being evaluated on unseen data. Then we trained three machine learning models: the random forest, XGBoost, and support vector machine. And of course, to evaluate the models, we used key metrics such as MAE, which measures the average prediction, the MSE, which penalizes larger errors, RMSE, which express error in the same unit as the rice yield, and the R squared, which shows how well the model explained the variation in the data. For the rice, to ensure that the results were reliable, we also applied the tenfold cross-validation, and in this method, the dataset is divided into 10 subsets and the model is trained and tested multiple times. Of course, for the rice yield prediction, the predictive algorithm that performed best among the three algorithms mentioned is integrated into a user-friendly web application. And for the web application development, the application includes the following key features: the historical dashboard, user input interface, real-time predictions and results to predict price yield, and provide insights to research and policy makers. So now you can see this slide. So this is the pre-processed data set used for modeling. Then the next slide compares the actual and predicted rice yield values. So a closer match between the two indicates better model performance. And based on the result of the metrics, the MAE, MSE, RMSE, and R squared, the random forest achieved the best performance with the lowest MAE, MSE, and RMSE and the highest R squared value. The XGBoost also performed well and produced competitive results. However, the SVR showed lower accuracy, indicating that it is less suitable for this data set. And of course, the cross-validation results further confirmed that random forest and XGBoost are reliable models. Then to get if there's a significant difference between the models, we use the ANOVA. After that, we get the 2-case HSD test for pairwise comparisons of model performance across the different metrics to determine whether the differences in model performance are statistically significant. So this allows to go beyond simple comparison and confirm that the differences observed are meaningful. So this strengthens our confidence in selecting the best performing model. So this slide continues the pairwise comparison result from the 2-case HST test. So together, these findings show how the model differ across multiple performance measures and provide deeper evidence regarding their predictive capability. Of course, we also analyze the training time to evaluate the computational efficiency. Of course, this is important because a model should not only be accurate, but also practical for real-world use. So this slide shows the training time of random forest and XGBoost. Then this slide shows the rice yield prediction user interface of the web application. So the interface allows users to input the needed agroclimatic values like the season, dew point, wind direction, sea level pressure, visibility, area temperature, humidity, and etc. So the interface allows users to input. So this demonstrates the practical application of the study by translating the machine learning output into a form that users can access more easily. And aside from the prediction page, the system also includes a dashboard. And for the conclusion, of course, based on the results of this study, we conclude the agroclimatic data can be maximized to develop predictive models that support better farming decisions. And among the algorithm tested, the random forest model emerged as the best performing model for predicting rice yield. Integrating the predictive model into a web application enables more accessible and real-time agroclimatic decision-making for users. So overall, this study demonstrates that machine learning has strong potential as a tool for improving agricultural forecasting in the Ilocos region and in the Philippines as a whole. So we recommend the inclusion of soil properties or irrigation conditions or pest occurrences and farm management practices. So we also recommend the use of time series analysis to better capture improvement is the integration of automatic data collection from the model may be expanded into a more comprehensive decision support system. So finally, we recommend conducting a user acceptance testing to allow how usable, understandable, and helpful the application is for its intended users. So thank you. So that concludes our presentation. And thank you very much for your time and attention.
Hello.
Hello, sir.
Yes, thank you for the presentation. So you have identified one problem and applied well-known
Yes.
machine learning methods to solve the problem. When you're submitting your research, what is expected? What modifications you have done in the technique or in the proposed methodology? So can you elaborate whether you have modified any technique or modified the methodology?
What, sir? Can you repeat the question?
What is expected in any research work? Modification in the existing literature, modification in the existing method or methodology. But I have not seen any changes in the modification in the known methods of machine learning.
It is a modification in the traditional yield prediction.
Whether you have done
Yield
any
prediction.
modifications?
In the model, we modified we performed fine tune with the models to get a more suitable result.
My observation is you have used existing models. So for future work, you try to build new models, maybe hybrid models for your prediction work, classification work.
Yes,
Thank
that
you.
will be considered for future work.
Yes, thank you.
Yes, just a comment. You say you use 3 algorithms, then you choose the best one. As we know, every technology has got its limitations and all those things. I wanted to know in terms of data size. You said the best one. In terms of data size, what is the size which this model can handle? And then what was basically the limitation for the model? And then the last one, you show as a web application. Have you developed a prototype or that the final product? Thank you.
For the data size, it can handle like hundreds of thousands of data, and of course, we chose the best model, which is the random forest, because it can handle nonlinear relationships and it has and overfitting. And regarding of the interface, so it was the design and develop web application and not just the prototypes.
Okay, thank you very much.
Thank you.
Okay, thank you so much, Samantha, for your presentation. So next we have Shankar Lingam to present his paper. So is Shankar in the meeting? Okay, I think he is not here, so we can proceed with the next presentations. So we have Bao Fan Gia to present his paper titled as Implementation of RAG Techniques for Vietnamese Public Investment Law. So Bao, are you there in the meeting?
Yes, I'm here. Can you hear me clearly?
Yes, we can hear you. You can start your presentation.
It's okay. So I hope that you can wait me a little bit to share my screen.
Yeah, I stopped my screen.
Can you see my screen right now?
Yes, it is visible. You can start.
Okay. 1 minute, I will. Oh, wait a minute.
Slideshow.
So, okay. Hello, everyone. Welcome to my presentations. Now I will introduce a little bit about our research, which relate to the implementation of RAC techniques for Vietnamese public investment law, which is the application, AI application in the legal field. Um, First of all, I want to introduce a little bit about the problems of our research. Why we choose this topic. You know, nowadays the legal field is very important to many people. So the system of legal document is very massive, complex, and it's hard to approach for anyone. So it's constantly changing and supplemented too. The legal language is is very dry for and which with many specialized terms it's very difficult for everyone who don't know any or don't know about the law or don't have any knowledge about this field. Um, the current AI tools such as ChatGPT or Gemini cannot give the precise answer because I don't have the special data for answers. So that's why we can see that this problem, and we solve in this research, we solve these problems. Why don't we build our own virtual assistant in the legal field? We decide to apply the modern technologies in AI, the technique like the RAG, uh, apply the models like such as text to speech, speech to text to build a virtual assistant that helps answer questions in Vietnamese public investment law. About the methodologies, the related work, and the improvement, our improvements, we will uh, we will develop two kind of brand, two type of brand. We see that the basic pipeline of brand is not enough for our solution, so we also build two type of brand which serve to comparison in the conclusions. First is hybrid search rack, which only use the BM25 algorithm, which is the keyword search, and the next is the vector search. And the next is the graph rack, the new type of rack which use the RAS database. I will store the data in the RAS database, and we will query to get the relate documents with the query. About the model in the architecture, we will select some models such as the embedding model, vision language model, and in these models we survey on the socket survey with we find out the solder of in the models. Such as in embedding model, we choose the BGE M3, which is very high results in benchmark for the language for any language, many language. The vision language model, we choose the Qwen 2.5 VL, which is also get the high performance over the resource we must use. About the other model, like the speed to text model, we choose the Whisper Large V3 Turbo. Text to speech model, we use the Kogi ICTIS V2. And the final is the re-ranking model, which include the BGE re-ranking V2 M3. These are the best model over the resource that we can have, and so yeah. In this research, we fine-tuning the models, which you use some firstly we fine-tune the embedding model. In this process, we fine-tune with the loss function. Is the combination of two loss. First is the multiple negative ranking loss, which means that we use the other records in the training data as the negative one compared to the related document. And next we use the second is the Masharska loss, which is like the Masharska Tsar in Russia, which means that with the in decreasing of the dimension, the quality of embedding or comparison is still the same between if we decrease the dimensions. The next is we fine-tuning the visual language model, which there are some results for our training process. We choose it because it's need low resources and also have the time and quality still afford our expectations. About the fine-tuning model, these are some hyperparameters that we set for our training process. These parameters we get is from the trial and error processing that we try the hyperparameters, then we benchmark the model. After that, we will adjust these parameters. About the evaluation, so we will test about our solution performance. About embedding model, you can see that on the left is the benchmark of our fine-tuned embedding model. In general, fine-tune consistently improves the retrieve performance across all dimensions. Especially you can see that for the 8 dimension setting, the accuracy for the accuracy one, which means that the accuracy for when I retrieve one document is increased from 57.6% to 73.9%, and the accuracy for 10 improved from 90.7% to 97.1%. About the RAG configuration evaluation, you can see that after after use the AI new techniques like fine-tune embedding model, BM25 algorithm and the ranking model, the fine-tune VLM, the accuracy increasing strongly is from 74.6% to 98.2%. Yeah, you can see. About the evaluation of the output, which means that we test from the test data to test data, you can see that the accuracy. There are 3 methods. First, we test on this data on the GPT-4o and graph RAG and hybrid RAG. We can get the accuracy as in the table. The reason for this that RAG method is capable of retrieving information from unstructured data, but when the graph RAG is more suitable for structured data. GPT-04 don't have enough the information about Vietnamese law, so its answer is worse than hybrid RAG. In conclusion, in this study, experimental results demonstrate that the hybrid RAG approach significantly improved the retrieval accuracy, and the answer has the superior performance compared to others. The proposed system did reduce the time required to search and interpret legal documents very clearly, thereby supporting investor and organization in complying with public investment regulation. So thank you for listening. Is any questions from us?
Hello, thank you for the presentation. So, which and how many documents you have used for your proposed methodology?
Can you repeat the questions?
Yes. How many documents and which documents you have used in your proposal?
Okay. So because this is the Vietnamese public investment law, which we crawl from the law company in Vietnam. they have the law like policy documents. So we craft from it. We it's the like the private data. So we have some policy to get it, and we will handle it and save it into vector database.
Whether you have compared performance of available large language models like ChatGPT for your problem.
Can you repeat? It's a little bit noise.
Whether you have considered the available large language models like ChatGPT for your
Yeah.
problem.
Problem with the large language model, I can still can hear you clearly, right? Can you?
So you can use the available large language models for your problem and compare the results with your proposed methodology.
Yeah, I use the large language model, yes, in our solution. So yeah, and I believe that there are some yes, we have some uh, uh, yeah, like survey the large language model is very important for us too, because to choose the best model for our solution, and choose, and also that afford the resources we have is very important, and we survey a lot for the large language model. Yeah, and yeah, this I think that this is the best the hard part, the hardest part for us. And next is we also I think that the handle the beside the large language model handle the data to ingest it into them into the vector database is also the very difficult process too.
Yes.
And
Yeah. I just need to get a clarification. So in terms of document, it's very broad. If you just say document, which type of, is there a specific document which you use, or what was basically the content of the document? Was what, they were having images, or it was only text, or what? How did you
okay,
handle
okay.
that? Thank you.
Actually, our documents is the government laws documents, which is only contain the text only. But we still have but our solution still have the ability to handle the input is the image. Yeah, a document. So in summary, the document is only text. Yeah, but
Okay. Thank you.
okay. Okay.
Okay, thank you, Bao, for your presentation. So next we are having Jyotika. Are you present in the meeting? Let me check once if she is present. Okay, so she is not here, so we could proceed. And then we have Shweta Jambukia. Are you present, or any of our co-authors are present? Okay, so she is also not present. Then we have Vinay RK. Are you present, Vinay? Rujal?
Yes.
Yes. So our next presenter is Rujal Agarwal to present his paper titled as A Real-Time Sign Language Recognition, a Lightweight Adaptive Framework. So you can start your presentation, Rujal.
Being visible.
Mm, 1 second. It is still sharing. You can try to reshare, please. Yes,
Is
now
it
it's
visible now?
visible. You can start.
Just a second. Yeah. So, good morning, good afternoon, everyone. My name is Ruzal Agarwal, and today I'm honored to present a paper real-time sign language recognition, a light adaptive framework. Our team includes Rohit Yanshi and our mentor, Pius Deviser, we have focused on bridging the communication gap for the deaf community through efficient edge-ready technology. Now, I'll move on to the next slide. Uh, so I've broken down the contents of this. So, so first of all, like I'll walk you through the problem statement and our choice of data set and our core architectural philosophy. Then we will dive deep into the comparative analysis between our hybrid model and um, the traditional baselines. And we'll be concluding with our performance results across the various hardware platforms that we actually use to compare. Uh, so the motivation for this work actually stems from the critical accessibility gap. While sign language is essential, human interpreters are often scarce and very expensive. However, creating an automated system the uh, faces the mobile bottleneck. So conversational sign language is incredibly fast. Like if a model takes 2 seconds to process half a half second sign, the flow of communication is lost. So our core objective that we aim to do with this was to achieve high accuracy within a strict mobile latency budget. So that would, in the way, help solve the major accessibility and the availability problems. Now, I'll walk you through the dataset that we used. The dataset that we used was Google Isolated Sign Language dataset. Uh, just a second. Yeah. The Google Isolated Sign Language dataset from Kaggle. This is a curated subset of the pop sign American Sign Language corpus. It contains about 100,000 video sequences covering 250 distinct signs. So, crucially, the dataset provides the media landmarks directly as vector data. Uh, this the Because we were provided with the uh, landmarks, we were able to bypass the computational cost of raw video processing, which could not be performed on our end. So this was provided by Google itself, and we tested on this. And the details of the dataset included there were 21 deaf participants, and in the as the framework was media input, it was the vector data provided directly. This eliminated the heavy processing costs. Now, there were specific reasons behind choosing this dataset. Uh, because our aim was to deploy it on like a like a selfie camera footage or edge devices. So we wanted uh, to choose a data set that did not actually was studio based. So there are many data sets that are available like MSASL, Microsoft American Sign Language dataset. So all like most of the data sets that are there, like MSASL and WLASL, they were basically taught in studio quality and in professional lighting. While the dataset that was used by Google was actually a real-time data set where backgrounds could differ, with people differed, and it was optimized for our use case. So, and there were many things that had to be considered while choosing the data set that there would be variable lighting and there were so we wanted to mimic what the real world usage and optimize the model according to the real world instead of a studio like a studio version of the data set. And we went through with that. And so the approach that we used for this was for our architecture highly prioritized speed and the generalization to a hybrid design. So for spatial understanding, we decided to use adaptive graph convolutional networks. So the adaptive feature is the key thing in this. it uses a learnable adjacency matrix, and which helps to discover like the semantic relationships between the joints that aren't even physically connected. So let's say there is like the thumb and the mouth during an eating sign. So for temporal, so we had to actually connect those, and we had to actually see the what was the relation between them in sign language, or when a sign is being performed. So those were something that had to be considered, which performed best using the adaptive GCM. Now, for the temporal modeling part of the thing, of the model, we replaced like the old slow sequential LSTM with the transformers, with the transformer encoders that were able to process entire sequences in parallel via self-attenuation. And as we were able to process the entire video sequence at once, rather than the way that the traditional long-term, short-term memory like LSTMs perform frame by frame, we were able to drastically reduce the inference time. And the inference time was a major thing that had to be reduced because for edge devices, like I told, uh, we needed to we needed to reduce the amount of we needed to process like a half a second sign in a half a second. So that was a major thing that was there. Now, uh, now the comparison of the like why the big models did not necessarily perform better were uh, the like a common assumption that is there in computer vision is like a deeper model, let's say a big model like a 3D CNN model will yield higher accuracy. Uh, However, in the smartphone data, uh, this correlation is highly breaks down very quickly because heavy models often overfit to background. So 3D CNNs usually, when we have a data set like MSASL, which is shot in a studio, uh, it is bound to overfit to the background noise, like the same curtain or a specific lighting throughout all the data set, and rather than actual hand motions. So the in real world environments, the background can differ, the lightings can differ, but in heavy models tend to overfit for the background noise, and instead of actually learning the relations between the actual hand motions. So our lightweight architecture uh, in this case wins by focusing on the pure sign of landmarks. So and like this is done as it is mathematically impossible for the model to see the background in our case because of the adaptive GCN that we have used. So this was one way we were able to optimize. Now, I wanted to do a speed comparison. For the model. So the fundamental bottleneck for the long-term, short-term memory is uh, sequential processing. So inference time grows linearly with the video length, or as we can see in the table that we have given, like the latency for the LSTMs is the video length, which is O of n, assuming that n is the length. So in contrast, our transformers have a maximum path of length of one between any two frames. That so we have also given the reference of like the paper neural IPS 2017. So it was established that self-attention layers connect all positions with a constant number of operations, enabling the faster inference required for mobile usage. So this was established by the paper, and we were able to do that and optimize and uh, actually reduce and optimize from the traditional LSTMs to the uh, parallel processing using the transformers. Uh, Now, for the comparative analysis, uh, this is the table that actually highlights the differences that are there and TPU optimized by LSTM, while uh, the by LSTM flattens spatial data and destroys the skeletal topology. Our adaptive GCM is optimized to actually learn explicit non-physical connections. Furthermore, our model is highly robust. The adaptive graph can actually learn to ignore noise or missing joints that would typically use that would typically cause a standard model to fail. So uh, this was one of the various reasons why we chose adaptive GCN plus transformer over the BiLSTM. Uh, so the TPU optimized version was tested in a Kaggle environment, and uh, the we were able to show the various things that we actually compared while we were trying to develop a framework, a light framework, which could maintain which could decrease the latency as well as the improve the performance.
Rujal, just a reminder, you'll
Yeah,
have to wrap up in 2 minutes.
sure. I'll just follow through. Yeah.
Yes.
Like now the efficiency paradox. In this case, we encountered what we call like an efficiency paradox. Logically, a model with an O of n square complexity should be slower than a one with O of n. However, the parallelism beats the sequentiality, while the transformer utilizes massive parallel matrix multiplications. It when done on like an NPU, it saturates all the NPU cores instantly, resulting in a lower latency. But processing 345 coordinates, like instead of 150,000 pixels per frame, we achieve negligible RAM usage and no overheating on the mobile devices. In the case of when we deploy it on ed- the edge devices like mobile or a watch device. Now, this is like the architecture for everyone. So here you can see like the full pipeline. The input sequence is 115 landmark over 537 frames. It passes through multiple stacked GCN layers for spatial feature extraction. Then into the transformer encoder layer, where the multi-head self-attention captures global temporal patterns using the proper format. Now, and then at the end, there is a final classification head that predicts one of the 250 sign classes that were defined in the data set. Now, the performance. So as we had trained for the state-of-the-art accuracy, so over 200 epochs. Now, our hybrid model achieved like a top one accuracy of 78.9%. As you can see, looking at like the training logs, you can see that the top five accuracy is close to 92 and 91.5, 91.75. The small gap, and there is also like the small gap between the training and the validation accuracy suggests that the adaptive GCN is successfully learning rules of motion rather than just memorizing samples. So this was a major thing that we had achieved. So yeah, like yeah, and so we were able to achieve generalization rather than just overfitting on the data set. Now we compared the BiLSTM as well. The BiLSTM baseline reached around 71.94. While it is a stable learner, it was fundamentally like inefficient on modern hardware. So its sequential nature actually prevented it from taking full advantage of the parallel architectures that were found in the current hardware that were the CPU and the GPUs that are being designed in the modern day. Uh, so finally, I just want to compare the hardware or the efficiency metrics on different hardware platforms. So on Kaggle accelerators, our model achieves a massive throughput of 400 frames per second compared to 25 frames per second for the BiLSTM. And even on a consumer grade Mac M2, we maintained a consistent lead in throughput. This confirms that our framework is optimized for the edge devices. Yeah, and uh, that is about it. Uh, Thank you.
Okay, any of the session chairs has any questions for him?
Yes, hello. Thank you for the presentation.
Yeah.
My question is how you have handled the background noise and light variations.
So the adaptive GCN, the adaptive GCN model is there. What it does is it does not care for the what is in the background. The graph convolutional networks is what happens is it actually maps the joints. So let's say we have our shoulders, we have our elbows, and we have our arms. What it does is it will use algorithms to connect those, and it will only be able to identify the movements between them. So potentially ignoring any background noise that might be there. So any different color or that will not matter because it will consider the skeleton part of it, the skeleton part of the human.
Okay. Whether the deep learning models like CNN and its variations are not sufficient to solve the problem?
The models, the heavy CNN models like 3D CNN, can solve the problem, but they tend to overfit. And and along that case, the 3D CNN models are very heavy. So a model which is in itself contains a lot of parameters is will be very hard to deploy in on a watch or maybe on a phone, and it would lack the computational complexity or the computational requirements that might not be there on a mobile phone.
Better you compare all the statistics in the result and discussion section. So how much time is required and what is the accuracy with the conventional deep learning models and its variations with your proposed architecture. Thank you, sir.
Thank you. Any other question?
Yeah, just want to in your context, is it the first time that the such system have been developed, or there are others which have been done before? If any have been done before, what is the difference? What is the contribution of yours compared to the existing one? Thank you.
So the existing models that are there in the market, what they are computationally heavy, and due to them being computationally heavy, the edge deployment of these devices is has not been done yet. And the model that we're currently using, it solves both the problems. It solves the problem of accessibility and the edge deployment because of the low latency as compared to the heavy models. So when you go about seeing like the research on this also, the heavy models are able to achieve a very high accuracy on data sets like MSASL, but the they tend to overfit on the data set, and due to their large size, they are not deployable. So our goal was in this was to actually develop a lightweight adaptive framework, which would actually adapt to the background, which would actually adapt to uh, in whatever background you are, in whatever lighting you are, and would majorly focus on uh, conveying the information between from like a deaf person to like a person who does not know sign language, to bridge that gap and to bridge that communication gap. That would be helpful. Yeah.
Okay, thank you very much.
Okay, thank
Thank
you,
you.
Ruchel, for your presentation. So, next we have Mr. Shankar Lingam. Are you present in the meeting?
Yes, madam. Yes, madam. On behalf of Shankar Lingam, my first author, Praveen, will be proceed, ma'am.
Okay, so he's here to present his paper titled as Harnessing Artificial Intelligence in
Yes, madam.
Social Media Marketing for Promoting Sustainable Consumer Behavior in
Yes,
the
madam.
FMCG Sector, a study in Telangana State, India. So you can proceed with your presentation
Yes, madam.
and
Yes, madam.
strictly finish it under 8 to 9 minutes.
Yeah.
I'll be giving you a reminder.
Yes, madam. Yes, madam.
Hello, good afternoon. Hello,
Good afternoon, sir.
there's my presentation harnessing the artificial intelligence social media marketing. for promoting sustainable consumer behavior in FMCG. 6-star study in Telangana.
So you don't have a presentation?
Yes, ma'am.
Okay, so you can
Madam,
continue.
actually, yeah, we are presenting through PDF only, madam, and yeah, he is my first scholar actually. This is the first presentation from his end, madam. So he is very new to this online presentation and everything, madam. Kindly support all the way,
Yeah,
and
sure,
he
sure.
is the
That's
PhD
fine.
scholar, madam. And Praveen, please proceed with the purpose of the the objectives of the paper and the study the what is the pertains to this particular investigation. Okay, na? Please
Yeah.
proceed.
Oh, subject. The interaction of artificial intelligence in social media marketing has because the way of companies, the fast moving consumer goods FMCG sector. This consumer is the study invest the AI driven strategy the implied the promoting the sustainable consumer behavior. Introductions the fast moving consumer goods FMCG sector in Telangana a significant contribute the region's economy. Economy is the wide the range of food provides including the food and beverages, personal care, household goods, and over the counter medicines. Hello.
Yes, Praveen.
Yes. The object is
Yeah, please continue.
the
Praveen,
key
is there
objectives of
any technical issue?
yes, ma'am. Signal problem.
So you resolve the issue till then I will take the next presentation. Okay, so next we have Vinay RK. Is he present or is any of his co-author is present?
Yeah. I am Vansh. I will
Yeah.
be presenting the offer.
Okay, so he is here to present his paper titled as Real-Time Multi-Object Detection and Tracking for Autonomous Systems Using Ultralytics YOLO. So
YOLO wait,
yes,
yeah.
yeah, you can start.
Yeah, I will be sharing my screen.
Yeah.
So it's visible, no?
The meeting is visible, not this presentation.
Okay, just a minute. Hello, now it's visible.
Yes, it's visible. You can start and wrap it up in 8 minutes.
Yeah. Good afternoon, respected panel members. I am Vansh from NMIT. Today I will presenting our paper titled Real-Time Multi-Object Detection and Tracking for Autonomous System using Ultralytic YOLO V8 version. So basically this project was developed in a real-time intelligence system which is capable of both detection as well as tracking multiple traffic objects on the video stream. So, like we have faced in real world automation, that understanding the environment real time is critical. So, our main work on project was to focus on building a system which is both accurate as well as fast enough for the real time application. So, next we'll to start with a problem statement. So, the main goal of our project is to design a system that can detect vehicles, pedestrians, traffic signs, and traffic lights from the traffic videos using the deep learning techniques. Like we have used a CNN for the detecting the which object it is, which is whether it's a vehicle or it is a two-wheeler or three bike or a car. Then the main challenges is in traffic environment, there is a dynamic and complex. It means where multiple objects appear simultaneously, and it can be a multiple objects can move at a different speed, and multiple objects can be overlap each other. So it is a challenge. So rather than a detection problem, but also maintaining the continuous tracking of the object across the frames is also the main problem. And next, coming to a literature, we gone through a many literature survey, and we found that the many literature are using the many different models also. Like we have gone across 20 to 25 research paper, and we have mentioned the 10 research paper. So outcome of the all the literature survey was that we analyzed the multiple research survey. Among that, many have used the YOLO based model, and also they have used the faster RCNN SST edge based detection system. So this models also shows a good performance in object detection, but they also have a many limitations. So many systems focus only a specific object categories like only vehicles or the pedestrians. They have not included the both, and many models are trained on static images rather than the real-time video streams, and we have included it. Then the limited were commands like detection and tracking. Unified pipeline they have not done. Like different research people have done detection, and they have not unified pipeline, both detection as well as tracking. And some methods have high computational complexity also, so which is unsuitable for the real-time issue. So there is a clear research gap that we have built the end-to-end system which can detect both tracking detection and as well as tracking in the multiple traffic objects. Then is the motivation. Our motivation comes on it to improve the road safety and as well as the monitoring the traffic and the autonomous driving system. As you know, sir, there will be a human error. So this is the biggest cause of accidents. So if the vehicles only understand their surroundings in the real time, so it will be significant reduce their risk. So our goal is to build a system which capability of autonomous systems like both detection and as well as tracking. And the main objectives of our project was to detect the multiple traffic objects accurately using the deep learning and to track the object across the video frames with the consistent ID. For this, we have used the byte tracking. Then to include the traffic sign as well as the traffic light recognition. Then is to build a unified real pipeline. It means both detection and the tracking in a single model. And we have evaluated the performance using the matrix like map 50, accuracy, precision, and the recall. So, yeah, this is the objectives of our project. Next is the framework. We start with the video input and processing. We accept the input from the CCTV or a dash cam, or we can only manually record the video and we can train it. Then we have extracted the frames of the video and resize into the YOLO V8 version, and uniform processing is applied. Then we have applied the ML techniques to reduce the noise reduction, brightness adjustment, and all. Then we have for the object detection, we have used the YOLO V8 model, which is a load pretend YOLO deep learning model, which detects multiple classes. Like there will be a classes bikes, vehicles, pedestrians, and the signs of the traffic signs and lights. So the output will be in a bounding box, labels, and the confidence code. Next is the object tracking and the annotation. We use the tracking algorithm. We have used the byte track algorithm, which gives the unique ID for the each detected object with the consistent ID for the tracking. Then the result generation last we reconstruct the entire frames into an output video. And initially we have evaluated the system using the accuracy, detection rate, and the frames. Yeah. Next is a framework. So our system is built in using the technology like YOLO V8 for the object detection. It is a one-stage detector, which means it performs detection in a single pass. It making it very fast. So YOLO V8 is known as very fast and accuracy. Next is the byte track, which is used to assign unique ID to each object, ensuring the consistent tracking across the frames. Next, we have also used the OpenCV for the extracting frames from the videos and generating the output videos. There will be a video for the extracting the frames. We have used the OpenCV, and at last, after detection and tracking the frames, we will convert into the original video and we will output the video. So, so only YOLO V8 provides a very good balance between the both the speed and accuracy. Then comes to the method. Evaluation matrix. So we have gone to the many evaluation matrix like precision, which defines the how accurate the detections are, and the recall, it tells the how many objects are detected correctly. Then is the IPS, which is the bounding box, it checks the quality of the bounding box, and the FPS, it is a real-time performance. Yeah, next is the methodology. Our system follows a step-by-step pipe. It is a pipeline. Like first is a video acquisition, where we collect the input video from a traffic videos or the data set or the manually, as I told. Then is a frame extraction. We have used the OpenCV to resize to match the YOLO V8 version and to apply the pre-processing like normalization and the noise reduction also. Then is the object detection, where you have to use the YOLO V8 model, which detects the objects such as vehicles, pedestrians, traffic signs, or the obstacles in the each frames. Then is the object tracking. For the object tracking, we have used the byte track, which assigns a unique ID to the each objects in a detection and maintains it across the frames. Total how many frames it will maintain across the all the frames, and at last it will make the video. Then the annotation, we draw the bounding box to the each objects with the label and the tracking ID. The tracking ID will be unique for the all the objects. Then the at last the output generation, it combines the entire frames and produce the final output video. Uh, then performance evaluation, like I told you, it measures the accuracy, pitch, recall, and FPS. Next is the challenges. We have faced many challenges during the project. Like first is a real-time processing constraint, which balance the speed and accuracy. It is a difficult. So we have used the YOLO V8 model. Then is the multi-class detection complexity. There will be different object types varying size and also the appearance. So it will be difficult. Then is a small object like distant objects are very hard to detect. Then the occlusion and motion blur, so objects may be partially hidden or blurred, so it will be very difficult. Then the class imbalance, like some class will be dominant, like there will be a more cars images or there will be a more pedestrian images. So many of the detection will be cars or the pedestrians. So based on the majority class which we have given. Then is the tracking consistency. It mentions the same ID across all the time. It was a challenging task. So to overcome the challenges, we have used the YOLO V8 pre-trained model on the COCO dataset. COCO dataset almost contained the 330K images and with the 220K labels. So there are the many images and the many labels in the COCO dataset. So we have used with the YOLO V8 for the input detection capability. Then we applied the data aggregation techniques to enhance the data quality and as the variability. Then we perform the class distribution analysis for the balancing the data set classes. Then we have used a bytrack algorithm for the stable tracking across all the frames. Then we optimize system for the speed for the real-time performance. Then the result, like you can see in the first image, like detection by class, there are the cars images detected more and the traffic light. These are the problem. Then the confidence score distribution, like this, you can see the matrix also. So our system has the following matrix, like map 50, it is showing 52.11%. It means 52% predicted boxes are accurate to the actual boxes. So according to industry standard, it must be 50 to 60%. So our is in between. So it is a good. Then there's a precision 63.42%. It gives the how many classes are predicted correctly. And the recall also gives the how many classes are actually predicted correct. Then according to industry standard, all these matrix will be satisfied. Then the average FPS motion we achieve 62 FPS. So which is well above the real time. According to a real time requirement, there must be a greater than 30 FPS. So we got the 62 FPS. So it's nice. And the inference time is 10.10 second, 10.10 millisecond. It across the frame it detects and track in the 10.2 millisecond variations. Then the video FPS also 62 FPS, which must be greater than 25. Yeah, it's greater. Then finally, in conclusion, we developed a real-time multi-object detection, which the tracking system, which use the YOLO V8 as well as bytrack. So yeah, we have gone across the 25 research paper. Thank you. I'm ready to answer any question.
Any questions for him?
No, no question from my side. Thank you.
Okay, so we will proceed to our next presenter.
Okay, thank you.
Yeah, thank you. So we have Ishwar Kaushik. Are you present in the meeting?
Am I audible?
Yes, sir, you're audible. So, Ishwar Kaushik is here to present his paper titled as Speckle Award Gated Cross Attention Fusion Network for SAR Optical Cloud Removal. So, you can start your presentation.
My screen is full.
Wait. Let me Yes, your meeting is visible, the screen is not visible. I mean, the presentation is not visible. Can you move on to the presentation, please?
Is my screen visible?
Your screen is being shared, but the presentation is not visible. You have to share the entire screen, not one particular window. You can try to reshare it, sir. Stop sharing up in the red. Yeah, you were going right actually.
Is it visible?
Yes, it is visible. You can start.
This is Ishwar from Andhra Pradesh. I am currently pursuing my BTech in computer science engineering from Amrita Vishwavidyapeeth.
Just a reminder that you have to complete it within 8 to 9 minutes.
Okay, ma'am.
Yeah.
Today our topic is Pickle Aggregated Cross-Attention Fusion Network for SAR Optical Cloud Remover. Uh, uh, this is uh, into the problem statement. Optical satellite image is nothing but that image what we have will be seeing in the Google Maps window. It is an optical image where we can see the clouds and all the stuff. Where the SAR image is an image which can it can get the information from this image as this it goes uh, in SAR image, we can get the information from the cloud under the cloud part. It can penetrate into the cloud and get the information from it. Uh, this is the cloud-free image, optical image. Our problem statement, satellite images are using satellite images. We are doing some like agriculture context disaster management. For our problem statement motivation, recently four landslides happened in Wayanad. Um, because of this, not properly disaster management. In this, we are planning to take the cloud from the optical image using SAR corresponding SAR image using cross-attention mechanism speckle gated module. Dataset used is a publicly available large dataset. It contains of 60,000 triplets. Each triplet contains one SAR image, one optical cloud-free image, one for the validation, and one cloudy image. Cloudy image for our as it's a very huge data set, we have taken the subset of it. It contains for the training set we have taken this 33,000 triplets where it contains winter and spring. As in winter and spring, we have not used it, so we have done it. For the validation, we have taken 7,000 triplets, and for testing set, we have taken some 7,000 data set. In literature survey, we got to know that people are using the deep learning techniques like CNN and cross-attention mechanism, and they're using the some kind of vision transformers for it, SAR optical using CNN networks like SAR encoder and optical encoder for this. We have found this. There are no there we have found this. Either they are taking directly SAR image as SAR image consists of this speckle noise. So so we would want to in this we want to add that speckle aware module and cross attention module. let us comes to this is our architecture diagram. Uh, our model architecture diagram we are taking a cloudy optical image and a corresponding SAR image. We are passing into the two encoder. One is the optical image is passing through the optical encoder, and SAR image is passing to the SAR encoder. In this encoder, we have three CNN blocks. CNN first block, it contains input channels of 13 and output 64, and we are downsampling it. Again, it is downsampling. Downsampling similarly, we are doing it in the SAR encoder. Compilation block. Uh, in this SAR channels, we have two bands, so two channels useless to 64, and we are downsampling and passing through another. We are getting the output of this, and we are passing to the global cross attention block where the cross attention happens. Here the query is the output output of the optical encoder, and the key value pair is the SAR optical SAR encoder uh, encoder output. We are passing as the in the cross attention mechanism. We are getting the corresponding cross attention for the query using this key value. As as SAR images can penetrate into the cloud, so we can get information from the cloud under the parts under the cloudy part. So we are trying to use the cross attention mechanism. From this cross attention mechanism, we are able to get the attention from the under cloud images and passing through the uh, for this non-cloud the cross attention in the cross attention for the non-cloudy pixels in the optical encoder it will be less, and for cloudy the cross attention will be the more, and we are passing, then the output is passing to the speckle gate module. In this module we have um, um, in this module we are taking the confidence the spatial and the channel encoders. Like it is also CNN, we are multiplying the both crossfit the signal and the crossfit the confidence. If the confidence is less, we are down. If the confidence is equal to 0, we are taking the cross attention pixel of that SAR. If the confidence is 1, we are taking the cross attention pixel, and we are passing it to the uh, refinement block. Here the fusion happens. We are fusing the uh, this optical encoder block and the crossfit block in the fusion block, and we are mixing it as here for the cloudy pixels, cloudy feature maps in the these will be the high. So we are fusing, and for non-cloudy it will be low. We are fusing it, and we are passing it to the decoder. Um, decoder. Here uh, we are upsampling the image as we have downsampling. We are able to get the uh, non-cloud uh, non-cloudy optical image. Uh, we have taken the fusion from the research paper called as GLFCR, the base model, through which we have from the base model we have taken the this pre-processing techniques, and we have modified the architecture from him. Uh, and we this is our proposal model. Uh, in the fusion strategy, he is using global local fusion. We are using global cross attention fusion. The attention type is he is using swing transformer. We are using global cross attention fusion. The we are using the separate speckle gate for this. The gating model expert and learnable. The reconstruction quality is better than ablation study. As we want to know whether speckle gated module is performing well or not, we have done this ablation study. In this ablation study, if no denoising, if you directly take the SAR image, you are getting the PSNR value 31.61. If you are using denoising, we are getting 33.94 PSNR value. If the proposed model, we are
Ishwar,
getting.
just a reminder for you, you have to wrap up within 1 minute because we are short in time.
Oh, okay, ma'am, okay.
Yeah.
This is 34. This is the denoiser. This is the denoiser. These are the evaluation metrics what we have used for the model PSNR, SSMI, RMSE, SSMI. The proposed model is performing better in all the conditions except this LPS. It is uh, uh, because it is this evaluation matrix tell us how for the human eye how this is smoothing or how it is feeling. Here we are not able to get it, but we are able to get in the PSMR value, SSMI, and SAM. This is the output for our proposed model. These are the cloudy optical images. These are the corresponding SAR images. This is the output of our proposed model. These are the ground truths. And these are the references to use. Thank you.
Thank you so much, Ishwar, for a presentation. Any questions from him from the session chair sides? Amol sir?
No question, madam. From my side.
Okay. Mabanza sir, any questions?
Yeah, so it's a good presentation. Sorry, but I could not hear it properly. It was noisy. So tell me, I see you're working with image in terms of data set. So the size, because there are different type of image in terms of size and then format.
Yes, sir. Yes, sir.
So when it comes to your model, so which one does it accommodate? Thank you.
Sir, sir, we
Hello,
have.
can you hear
Sir,
me?
your sir, sir, can you once again repeat the question? I didn't get to.
No, I say I saw you are working with images, so there are different type of image in terms
Yes,
of
sir.
format and compressions and all those
Yes,
things. So in terms of data, the size and the data set of your model, how does it
yes, sir.
accommodate those? Thank you. Or is it for a specific type of image or any type of image? Thank you.
Yes, sir. It is for the satellite images, sir. For .TAF images, it is particular for .TAF images. You can see the code. You can see the code, sir. For preprocessing, we have taken for data loader. We have considered this this data set. From this, we are getting the we are data set and we are separating into training, testing, validation data set, data loader. Uh, it is this image, this model is particularly for the .af images.
Okay, thank you very much. That's all from my side. Thanks.
Thank you.
Okay, thank you so much, Ishwar, for your presentation. For our next presenter, we have with us Safia Karimova to present her paper titled as The Expanding Role of Artificial Intelligence in the Modern World. So, Safia, are you there in the meeting?
Yes, can you hear me?
Yes, you are audible, so you can start with the presentation. You need to finish it in 8 to 9 minutes strictly because it's already time.
Okay, I got
Yeah.
it. Can you see my presentation?
Yes, you can continue.
Okay. So it is a great opportunity to now to speak my presentation. I would like to talk about about the expanding role of artificial intelligence in a modern world. So, artificial intelligence is a rapidly evolving technology transforming economies and industries worldwide. It has shifted from rule-based systems to data-driven approaches like machine learning and neural networks, enabling widespread use in sectors such as healthcare, finance, and education. AI improves efficiency in decision-making, but also raises challenges related to ethics, privacy, and employment. The study highlights Uzbekistan's efforts through national strategies and digital programs, emphasizing that successful AI adoption requires strong governance, skilled professionals, and responsible human-centered implementation. Artificial intelligence enables machines to perform human-like tasks and is widely used across industry to improve efficiency. While it offers major benefits, AI also raises concerns about bias in job laws, requiring ethical regulation. Uzbekistan is developing AI through national strategies and investment in education and technology, aiming for innovation and sustainable growth. AI is also playing an important role in solving global challenges such as climate change and healthcare improvement. Its future impact will depend on balancing technological progress with the human values and implementations. The methodology data for this research were collected from peer-reviewed journals, open access AI datasets, and industry reports published between 2015 and 2025, including sources like Google Scholar, IEEE, Explore, and the Science Direct. Key datasets such as ImageNet, Coco, and OpenAI GPT benchmarks were analyzed to illustrate advances in machine learning. ImageNet, introduced by Fei Li and her team in 2009, is one of the most influential datasets in AI, with over 14 million labeled images across thousands of categories. It enabled significant progress in computer vision. Its impact became clear during the ImageNet Large-Scale Visual Recognition Challenges (ILSVRC), especially in 2012, when AlexNet reduced error rates dramatically, marking a breakthrough in deep learning. This success led to the development of advanced models like VGGNet, Google LENet, and ResNet, improving accuracy and efficiency. ImageNet has since supported innovations in fields such as autonomous driving, medical imaging, and robotics, and introduced transfer learning as a widely used technique. However, ImageNet also raised concerns about bias and representation, prompting efforts to create more ethical and inclusive datasets. In addition, TensorFlow has become a key tool in modern AI due to its scalability, flexibility, and strong community support, widely used in both research and industry. Overall, the dataset and studies used the publicly available and applied for academic purposes with the ethical considerations such as privacy, bias, and fairness carefully evaluated. Now I would like to move to the tables. The first table, as you can see, represents a comparative overview of how artificial intelligence impacts different areas. First, in terms of performance and accuracy, AI has a very high impact. Modern models, especially those based on deep learning and transforms, achieve state-of-the-art results in fields like computer vision and natural language processing, enabling highly reliable and intelligent systems. Second, AI application across sectors also show a high impact. AI is widely used in healthcare, finance, education, and transportation. This application improves productivity, support innovation, and enhance the quality of services. Third, automation and operational efficiency are significantly improved by AI. Technologies such as chatbots and robotic process automation help automate repetitive tasks, reduce human error, and lower operational costs. Finally, ethical and social implications have a moderate impact but remain very important. Issues such as the privacy risk and job displacement highlight the need for proper regulation, and responsible AI governance. The next table is a key result and findings in artificial intelligence research. The second table summarizes key findings in terms of performance and accuracy. AI models consistently outperform traditional algorithms, leading to better automation, improved decision making, and more efficient handling of complex tasks. In, in application fields, AI is widely adopted across industries such as finance, healthcare, and public administration. For example, it is used in diagnostic, fraud detection, predictive analytics, and autonomous system, increasing productivity and innovation. Regarding to automation and efficiency, AI significantly reduced manual workload by automating repetitive and data-intensive processes. This leads to time savings, fewer errors, and higher operational efficiency. However, ethical and social challenges remain a major concern. Issues like algorithm bias, data misuse, and workforce displacement require attention, including the development of ethical frameworks, transparency, and regulation. Lastly, emerging trends show a growing focus on explainable AI, sustainable AI, and general AI system. These advancements aim to build trust, improve transparency, and ensure responsible development of AI technology. Now I would like to talk about summary of findings. The findings show that AI significantly enhances performance and accuracy, not only in Uzbekistan but over the world, through deep learning and transformer models, while its application across sectors improve productivity, efficiency, and decision making. Automation reduces human error and operational costs. But social challenges remain pressing concerns. Evidence highlights the growing adoption of explainable, sustainable, and human-centered AI approaches to address these issues. Overall, AI demonstrates transformative potential, provided technological innovation is balanced with the ethical governance and transparency. In Uzbekistan, AI development is a strategic priority under initiatives like Digital Uzbekistan 2030 and the National AI Development Strategy, targeting sectors such as healthcare, agriculture, education, and public services while promoting responsible use and local capacity building. The country's approach demonstrates how developing nations leverage AI for economic modernization and social development, balancing innovation with ethical consideration. Effective AI governance requires multidisciplinary collaboration among engineers, policymakers, ethicists, and industry leaders to ensure trust, equity, and societal benefit. Future research should focus on localized AI application and integrated technical, social, and policy frameworks tailored to regional needs. In conclusion, the current analysis offers full empirical and theoretical proof that the transition from traditional to smart banking represents a strategy for reducing NPLs in the digital age. The incorporation of diverse econometric techniques like fixed effects, panel estimation techniques, VIR model estimation for the dynamic relationship between the variables, and ARIMA forecast offers solid proof of the negative relationship between digitalization and NPLs. Thank you for your attention.
Okay, any questions for her?
Can you explain the methodology used to carry out the research? How you have done the research?
Please, can you repeat the question, please? I couldn't hear it clearly.
Explain the methodology used to carry out this research. How you have done this analysis?
The methodology in the methodology which in which you said aspect, I didn't hear that clearly. The connection is very bad.
Okay, no issue. Thank you.
Okay, Mabanza sir, any questions?
Yes. Can I see your slides on literature review, please? If you
Okay,
can
sure.
display it. Yeah.
Yeah. 1 minute. Yeah, literature review.
Yes. Tell me. According to what you present here, it's like you are doing a literature review of a systematic literature review. So tell me now, you have looked at so many publications. The publication which you have been looking at, what was the criteria? Are you just looking at the one which were published in English? Because there are some others which are published in different languages. What are those effects? Probably they are also talking about what you are, what was the
Yes.
scope? Because the way you presented it, it was like more broad. I don't understand. In the inclusion
Yes.
for your selection, what are the criteria which you use there in terms of publication? Thank you.
I find this information according to the Uzbekistan's information and from the Google Scholar that were related to the artificial intelligence. So according to this information, I made a literature review, and overall, I explain it and I wrote it in this presentation. I choose this topic because of the Uzbekistan is really development in artificial intelligence, but not enough. So I would like to enhance this field in the future. So and that's all. Yes.
Okay, thank you very much. Thanks.
Thank you. Thank you.
Okay, thank you, Safia, for your presentation. So, up next, we are having with us Shweta Jambukia to present her paper titled as Real Time Health Monitoring Using AI and Wearable Devices, a Survey. So, Shweta, ma'am, are you ready with the presentation?
Yes, I'm ready.
Madam,
Yes.
how many presentations are remaining?
More two presentations are remaining. Ma'am, I request you to please wrap it up in 7 to 8 minutes.
Okay.
Yeah.
Is my presentation visible to all?
Yes, it is visible, but it is not in full screen.
I have already done it. Maybe some delays. Now
It
it
is
is
on the
visible.
literature review slide. No, it is still okay. Wait. Yeah, you can try again. Present your screen again.
I have already present again.
Mm.
Is it visible?
No, the meeting is visible, not the presentation.
Okay.
You have to share the entire screen.
I have shared the entire screen.
Okay, what you can do is you can resolve the issue. Till then, I will take the next presentation.
Okay.
Yeah. So next we have Jyotika Yadav. Jyotika, are you present in the meeting?
Hello. Yes, I'm here in the meeting.
Yes. So Jyotika, she's here to present her paper titled as Predictive Techniques for Traffic Congestion Management in Intelligent Transportation Systems. So you can try start sharing your
Yeah,
screen.
is my screen visible to everybody?
Yes, it is visible. You can start.
Okay. Good afternoon, everyone. My topic of presentation here is predictive techniques for traffic congestion management in intelligent transportation systems. Hello, am I audible?
Yes, ma'am, you are audible.
Yeah. Okay. So see, traffic congestion is one of the biggest problems in urban today, because where with the increase in population, the number of vehicles on the roads are also increasing, which leads to very frequent traffic jams. And this jams leads to loss of time while traveling, fuel wastage, air pollution, and also economic losses. So to solve these issues, smart cities are adopting ITS, that is Intelligent Transportation Systems, which use sensors, cameras, GPS, and AI technologies to predict the traffic congestion beforehand so that they can be avoided later on. So my presentation focuses on how predictive analytics and various AI-ML models can forecast congestion before it happens, which allows authorities and peoples to take proactive actions. Okay. Yeah. So while I have done here a broad literature survey on various ITS applications. So mostly the surveys focus on ITS applications, but very few focus specifically on traffic congestion prediction. So post 2020, there has been a rapid growth in advanced in models like STGNS, that is spatiotemporal graphic neural networks, or transformers, or federated learning. But they were not well organized in previous reviews. So the objective of this paper is to study the congestion prediction methods post 2020 and to classify them into categories, to compare their performances, and to discuss their real world deployment challenges. So based on my literature review summary, there are various traffic prediction techniques that have evolved over time. There are classical statistical models like ARIMA and Kalman filter. There are ML models like SVM, support vector regressions, XGBoost. There are deep learning models like RNN, LSTM, CNN models, and then there are modern graph models also. So these are various models that have been categorized based on the different techniques and the data they work on, and they have been organized here that way. So what are my key findings from this research surveys? That STGNN models, they give the best forecasting accuracy, and transformers also handle long-term dependencies well when large city networks are concerned. Then federated learning protects privacy and it maintains good performance. And but the hybrid models, they show stronger performances when combined together. They bring robustness in real world conditions. So no single model is perfect, but when their combinations are used, they perform the best. That means the hybrid models are the best solution to the real world traffic problems today. There are various regression evaluation metrics and experimental protocols that were used to compare these models. To measure their prediction quality, researchers use various models like regression metrics, like when we are considering the speed of the traffic or the flow of the traffic, we use RMSE, ME, or R square, where lower error means better prediction. Then we use classification metrics like precision, F1 score, to predict the congestion levels. And we use operational metrics, which are important for real world deployment, where inference speed, model size, and energy consumption are considered. So a good model must only be accurate, but also fast and efficient. So this is a comparative performance of the various models that has been compared here. When comparing all the model families, the classical models turn out to be simple but scalable, but they have lower accuracy. Machine learning models have a moderate performance. RNN and LSTM have good temporal learning. STGNNs, they have excellent spatial and temporal learning. Transformers are very strong for long range forecasting and scalability. Federated GNNs have good accuracy with strong privacy, and hybrid models, they offer strongest overall, but they are more expensive. So therefore, modern AI methods, clearly they outperform the traditional approaches. So here we have the applications of ITS, that is Intelligent Transportation System. So where predictive models are already useful in real world transportation systems like adaptive signal control, where traffic lights adjust automatically based on future congestion. Then dynamic route guidance, where apps can suggest better routes before roads become crowded. Then incident detection, where accidents or anomalies can be detected beforehand and faster. And the 5G deployment, where roadside devices can make real-time traffic decisions with low delay. So this shows that the congestion prediction has direct real-world value. So, although the results are promising, there are several challenges which remain here in its implementation, like data sparsity, because sensors may fail or they provide the missing or incorrect values. Then there is generalization problem, because models trained in one city may not work in other city or at other junction. Then interpretability, that means deep learning models often they are black boxes and they are difficult to explain. Then the large models need powerful hardware, which increases the computational cost. So to conclude that since 2020, traffic congestion prediction has advanced significantly, and modern models have improved the prediction accuracy, scalability, and privacy. So predictive analytics is becoming the core or the basic of future smart transportation systems. It can reduce congestion, save time, lower the pollution, and improve urban mobility. Thank you. And these are the various future direction in which this research can be taken on. These are the key references, and that's all from my side.
Okay, any questions for her?
Madam, this is a review paper or you have implemented something?
Sorry, sir, you are not audible.
Madam, this is a review paper?
Yes, sir.
This is only a review paper?
No, sir, I have implemented various models, studied their performances, and then I have designed a summary of the model.
The results are not shown in the presentation.
Yes, sir, I have just reviewed the various models.
But where are the results? Where are the results? Can you show the result slide?
No, no, sir, I have not included that here, sir.
Then how we can say that this is a contributor paper? Okay, thank you.
Okay.
Banza sir, any questions?
No, I think Dr. Moll has covered what I also wanted to ask. I was thinking it was just a literature. So now she says she did some experiment which we did not see the result. So that was also my question. Yeah, thank you.
Okay, I think she's left the meeting already. So, do we have Shweta with us with the resolved issue? Shweta?
Yes, ma'am.
Yes. Please share your
Yes, I'm
screen.
here.
So, probably this will be the last presentation for today. Yeah.
Is the screen visible now?
Yes, it is visible. Yes, you can start.
Okay, thank you.
Yeah.
Today I'm present for the real-time health monitoring using AI and wearable devices. I have done the comparative survey. Uh, so we want actually to health monitor the patients remotely, real time and on continuous basis. So we want to go for the system which will be helpful for early warning systems, which will be helpful for immediate medical response. So for that, we have observed that patients can able to wear some kinds of devices, wearable devices, kind of wristbands, armbands, that will be helpful us to get the patient's health metrics, some physiological data. Patients can wear these devices. That is nothing but wearable devices. It's a kind of an electronic devices that will be equipped with multiple sensors, and that sensors are sensing the data. It will be helpful us to record, track, and analyze the health conditions of the patients continuously. So sensors we can include like ECG sensors, blood pressure sensors, oxygen monitoring sensors, or other stuffs, which would be helpful us to give and continuous data collections, and helpful us to long-term monitoring the data of the patients. Sensors can be attached to the devices. I have observed that some of the researchers have also developed some kinds of devices with this different sensors. Sensors can be helpful for the continuous acquisitions of the data. Sensors can be heart monitor sensors, blood cooker sensors, ECG sensors, right? That can be the sensors. These are the figures which represents the different sensors a patient can wear. It can have wristbands, armband. It can have pulse monitoring, blood pressure monitoring, and so. Uh, this wearable devices will be actually transmitting the data to some kinds of server or some kinds of healthcare facilities, which will be again going to be monitored by some kinds of professionals, and promptly we can provide some kinds of medical advice to the patients on the time. This will be helpful for reducing actually the workload of the medical staff. For example, there kind of some kinds of pandemic situation is ongoing, and we want to actually go for actually identifying the patients with no symptoms, patients with mild symptoms, or patients with severe symptoms. Then we can do these kinds of pre-screening on the patient's data based on their data, and we can actually reduce the loads, and we can actually helpful for locating the medical professional to actually the severe patients only, right? That we can do with the help of analyzing this kind of data that we can collect with help of wearable devices. So wearable devices like smartwatch, smart sensors will be helpful for doctors to actually monitor the daily activity of the patients, and it will be helpful for collecting day-to-day basis activity, and we'll have gather some data. We will going to analyze those data, and based on that we are going to monitor and diagnose the patients. But actually over here issue is we are going to collect the day-to-day data, so that's why data will be huge if we talk about even a single patient. So we need some kind of AI, ML, or deep learning kinds of models or techniques to handle such healthcare huge amount of data. So these kinds of systems can gather and analyze the data for actually giving the real-time feedback, and helpful to the medical professionals to take the appropriate actions based on the patient's situation. The collected data is actually then transmitted to the particular remote node or server. Then it is actually analyzed with the help of ML or DL algorithms to identify and classify multiple health issues. So this will be done basically for early disease detection or remote diagnosis. Fine. So this figure actually shows the different phases of developing an health monitoring system. So first of all, we will have some kinds of wearable devices.
Shweta, just a reminder, sorry to interrupt. You will have to wrap up in next 5 to 6 minutes.
Okay, okay.
Yes.
Fine. So first step is step in this phase. We have some kinds of wearable devices that can be able to be wear by the patient. Either it can be the wristband, either it can be the thigh band or arm band or something, which will collect the data. That device will contain some kinds of sensors, right? So we are going to collect this data. The data will be transferred to some kinds of node, and from that data we are going to perform some kinds of pre-processing techniques, and the features will be extracted with help of feature extraction techniques, and some kinds of modeling will be done. We can have some ML or DL techniques to actually train our model and then predict our disease for the patients. This is the phases of the real-time health monitoring systems. So there are some kinds of feature extraction techniques applied to the raw sensor data, and to identify the meaningful patterns from those data. then that extracted features will be actually given uh, as an input to the machine learning models to train those models to recognize the pattern, to actually predict or classify the different health conditions of the patients, and that will be helpful us to actually pre-diagnose the patients. um, these are the survey. In the survey we have gone for identifying the different health applications, which type of devices each researchers have used, which sensors or signals they have used for detecting or gathering the data, then the pre-processing techniques they have used, the data set, either the data sets will be created or publicly available data set will be used by the researchers, then the features they have used for the techniques that they have used for the modeling. These are all the survey techniques that we have used. So these are the my first survey slide. So actually researchers are going for monitoring and diagnosis. So for example, the first one paper they have used heart monitoring sensor, blood pressure sensors, oxygen monitoring sensors to classify their patients in different of health status, or we can also classify the different activities. For the example, the third paper they are going to classify in the activity class, like patient is walking, patient is running or lying down or climbing or so. Fine. So for that they have used different sensors over here. As we can see that IMU sensors they have used different sensors, and sensors can be placed on waist, seat and thigh also. Right. And from that they are going to use some kinds of pre-processing techniques. So over here they've used Gaussian noise or normalization and sampling techniques that can use. So different data sets are already available. Like this over here we have this data set, and real world HAR public data set is also available. If the public data set is not used by the researcher are actually using the device, and the device will be able to be worn by the patients, and that they are going to collect the data. Right. And different models they have used, like CNN, LSTM, and researchers have got 85-99% accuracy over here. Right. As such, these are the other papers. So over here we have multi-disease detection. What they are trying to do is they are trying to actually discover the COVID-19 diabetic and depressed patients out of the data. Fine. And have used the COVID dipped data set. For the diabetes they have used this data set and all of the stuffs. Fine. So multiple sensors also they have used, blood pressure monitoring. Also people are going to use the smartphone applications to gather those data and analyze those data, so customers or patients can also see what is going on with their health. And they have also achieved the 99% accuracy over here. These are all other papers that I have reviewed, and that is there in my paper. Uh, because of the time, I'm going on fast with this table. This is also another paper. This is multi-disease classifying. They are going to have ECG detection over here, and for that they have used MIT BIH arrhythmia database. The processing techniques they have used is normalization, and they have used deep neural network, and the features they have used are RR interval, QRS complex, the PQ and PR wave. Fine. And they are classifying this into the normal signal or abnormal signal, and they've got 99 for that. For blood pressure they have got 91% accuracy, and they have got used ECG and PPG sensor for that, and same way for other detections they are also getting some kinds of accuracy above 90 plus. These are all other papers. So basically, I have found out from this comparative analysis some issues and challenges are there. Basically, we need to have some kinds of data collected from the patients, and that data needs to be actually annotated and processed. That is also issue. And same sensor placement on the same person may have different motion patterns for the identical activities. That is also the issue. and the same sensors will react differently with the different age of the patients. That is also an issue. Next issue we are having is collecting and processing those data. That is also an some challenging. Next issue we are having is we have wearable devices. That device it itself is having limited batteries, because as I have said that we need to collect the data and send it or transmit those data to some kinds of server we have. So that transmission in turn will consume the more energy than the sensing of the actual health data. So that is also an issue. Next issue we have is as we are transferring the patient data, there is an issue of security and privacy also, right? So these are the challenges and issues I have found out. So this is my conclusion. uh, we can use RT techniques, AI-based technique systems with the wearable technologies to enhance the efficiency of the healthcare industries, to actually do the healthcare monitoring, diagnosis, and early disease detection by continuously actually monitoring the data. Uh, I have done the comparative analysis, which include the different architectures, techniques, data sets that is available and used by the researchers. Mostly, I have found that CNN, that is the deep learning model, and the combination of hybrid CNN and LSTM architecture is mostly used by the researchers. Will be helpful for this purpose to actually analyze the signals. And lastly, if someone wants to add something future enhancement to this, we can use explainable AI. We can go for providing the security to the data that we have transferred from the wearable devices to the servers, so we can do that part also. uh, that's the thing. So I'm wrap it up. These are the references that I used. Thank you.
Okay, any questions from anyone?
Yeah, thanks for the presentation. It was a good one. I did not properly get it. Did you develop something, or you are just doing a literature survey comparing the ones which exist? What was happening? Thank you.
No, actually, I was doing the comparison survey. It was a review paper. I have not developed anything, but I have just analyzed the things that is there for this purpose.
Okay. No, thank you very much for the clarification. Thanks. That's all from my side.
Amol
Okay,
sir, any
thank you.
questions?
No, madam, no question.
Okay, so this was the last presentation for today. So we have come to the end of this session, and I sincerely thank all our authors for their excellent presentations and the valuable contributions, and all the participants for being an important part of this international conference. I truly hope that this session was insightful, engaging, and inspiring for everybody present here. On behalf of the entire team, we thank you for your continued support, not just for this 11th edition, but for all the previous 10 editions of ICTIS. We look forward to welcoming you again in the 12th version in 2027 as well. So, all presenters will receive their digital certificates through emails within 2 working days, and the publication will be live within 7 to 8 months. So, we kindly request your cooperation with the ICTIS 2026 team. I would also like to extend my sincere thanks to both our session chairs, Dr. Natima Mabanza sir and Amol Admuthe sir, for expertly chairing this session. So this is a small token of appreciation on behalf of Global Knowledge Research Foundation and partners. So thank you all once again for your valuable presence. And before we officially wrap up, let's capture a quick memory of this. So I kindly request everybody to switch on their cameras, and I will take a group snapshot for this session. 1 second, let me stop sharing the screen. Yeah. Safiya, Ishwar, Kaushik sir, I request everybody. Yeah, thank you so much for your presence. Thank you so much. Stay safe.
Thank you.
Take care.
I just want to comment something on the Well, certificate of appreciation. I'm doctor, I'm
Yes,
not
yes.
professor. Thank you.
Oh, okay, okay, okay.
If you can fix that. Thank you very much.
Yeah.
Bye bye.
Yeah. Thank you.